Good evening to one and all. With immense pleasure, I welcome you to all to second session of the second day of our AICTE Training and Learning Adult Academy sponsored faculty development program on empowering education with the next gen computing, AI, Supercomputing and Data Science, organized by the Department of Computer Science and Application, Majlis Arts and Science College, Autonomous. In previous session, we explored the theoretical foundation of machine learning and deep learning, gaining conceptual clarity on models, algorithms, and applications. That knowledge forms a strong base for what comes next. Today's sessions marks an important shift from theory to practical implementation as we learn how to apply these concepts using Python. It is now my privilege to welcome our distinguished resource person for this session, Mr. Dilip Ji. Mr. Dilip has over 23 years of experience in software development, project management, solution design, and technical training. He has worked across diverse domains, including ERP, insurance, microfinance, education, and business accounting, demonstrating exceptional technical leadership and innovation. Currently, he serves as the head of the training department at One Team Solutions, where he also contributes to developing internal applications and skill enhancement initiatives. In addition to his industry excellence, he's a highly respected trainer, well known for his experience in Python, Django, machine learning, deep learning, JavaScript, ASP.NET, SQL, MongoDB, and modern web technologies. He has delivered numerous FDPs, corporate training programs, and academic workshops across various institutions, earning recognition for his clarity, hands-on approach, and deep subject mastery. Today's sessions titled Hands-on Machine Learning and Deep Learning using Python will help us bridge the crucial gap between understanding ML and DL concept and practically implementing them using real-world tools and code. Sir, we are truly honored to have you with us today and grateful for your time and expertise. To all participants, I encourage you to remain interactive and engaged. This is a valuable opportunity to gain practical experience. I extend a warm welcome to our respected principal, Mohammed Kutti sir, for his constant support and encouragement in conducting this FTP successfully. I'd also like to welcome Rafiq sir for his dedicated leadership and effective planning of this program. A warm welcome, Technical Assistant Ms. Chitira, and to our rapporteur Ms. Manchulayesh and Ms. Charanya, who will be deliver a vote of thanks. Once again, a warm welcome to everyone present here. Thank you. And let us begin the session.
Can you hear me?
Yes, sir.
Yeah. So thank you, Ajay Kumar sir. And so we can directly go to our session. So I am sharing the screen. So can you see my screen? Yeah. Okay. So last session we covered, or we had a very good section or very detailed session on machine learning and deep learning theory. So I am not planning to say any theories in this session because it's already covered. So we will have some programs in machine learning and deep learning, very basic programs. So we will get a good idea of how to do all these things in Python. So before start, I assume everyone knows Python. So what is Python? Python is a simple high-level programming language. And I just want to say something like I am not using any PPT because I want, so I am using Colab, so I can show the content and the code. I can do the same thing in this screen itself. So what is Python? Python is a simple high-level programming language widely used in machine learning and deep learning. That I think everyone knows that. So the reason it dominates ML or DL is because of its rich ecosystem of libraries like NumPy for numerical operations, Pandas for data handling, scikit-learn for ML algorithms, TensorFlow and PyTorch for deep learning. These are the different libraries we use for Python. So we know that Python is easy to write, easy to read, and perfect for experimentation, which is exactly what we need in ML and DL. So we are all we should know Python because Python has different applications. We can use Python for web application development. We can use Python for desktop application development. So we use Django or Flask. Django or Flask for developing web applications. Django is a web application framework, and for desktop applications, for GUI, graphical user interface development, we can use Python's built-in tkinter or pyqt or wx Python. So all these libraries are, or all these packages are available for developing these different type of applications. So Python is widely used in machine learning and deep learning. So we will go with Python. And before, so we need different IDs for Python. What do you mean by IDE? IDE means integrated development environment, correct? So we need we need some editor or some integrated development environment for writing the code. So there are many environments, but I am listing here only three. It's Google Colab and Jupyter Notebook or VS Code, Visual Studio Code. So we will demo the programs in Google Colab. So what Google Colab means, we don't need any installation. The code will run in browser. So free GPU available, easy to share and download notebooks. And another thing is Jupyter Notebook, great for data science exploration. That's another IDE. So another thing is Visual Studio Code. Visual Studio Code, good for larger projects. And other IDEs are there, PyCharm, all that type of IDEs are there. So we will use Colab for this session. Okay. So introduction to machine learning. I think I don't want to waste time by saying all these things, but anyway, we can. Machine learning is a subset of artificial intelligence that allows systems to automatically learn from data. It's already covered. It's a subset of artificial. It will automatically learn from data, and there are three types: supervised learning, and under the supervised learning, there is regression and classification. It means learn from labeled data. And unsupervised learning uses unlabeled data, discover hidden patterns, clustering, dimensionality reduction, then reinforcement learning, learn from rewards and penalties. Real-world use cases are email spam detection, classification, house price prediction for regression, and customer segmentation clustering. So these are the main machine learning process steps. These are all covered in the last session. So first we need to define the problem, then we need to collect the data. So we will get the data from lot of where we have some database in SQL Server or MySQL. So we can collect the data from there, or we have data in CSV or Excel files. We can collect the data from here, or web scraping also we can scrap the data from web. So likewise, we can collect the data. So after collecting the data, we need to clean and pre-processing. So we can say that exploratory data analysis. So in that process, we are cleaning the data and pre-processing. Then feature engineering. Feature engineering also, we need to remove some features, or if we need to add some features. All these type of things will come under this feature engineering. Then we need to split the data into training set and test set, testing data. Then after that, we need to select a model. So a lot of algorithms are there, a lot of models are there. So we need to apply some algorithm there. Then after that, we need to train the model. And after the training, we need to evaluate the model. And after that, we can deploy the model. So that is the machine learning process steps. And common Python libraries for machine learning category, data handling. For data handling, we have two libraries, NumPy and Pandas. So NumPy and Pandas are two libraries for manage and analyze data. Then for visualization, we have two libraries, Matplotlib, Seaborn. So Seaborn is developed from Matplotlib. Matplotlib is the main library for that. So it's used for plot charts and insights. Then ML algorithms, scikit-learn. Scikit-learn, we use that library for train and test ML models. Then deep learning frameworks includes TensorFlow, Keras, PyTorch. So these libraries we use for build deep neural networks. So we will start with, we can see how can we use Google Colab. So if you don't know, I think everyone use that, but I will show. So we can search for that Google Colab. So you can click on that link. So we already signed in Gmail. So this is the Colab. So here we can use this Colab new notebook. It's loading. Yeah, this is the IPython notebook. The good is that this Google Colab file can be shared like Google Docs or Google Spreadsheet. So we can share to someone and we can download or we can upload or we can use like that. So this is for typing some text and this is for adding code. So we can write a Python code. So in order to run this, we can click on this run cell icon. So here we get the output. Here we get the output. So we will use like this. Okay. And I will show, first I will show a regression program predicting price based on house area. So this is a simple linear regression demo. So first we need to, I will copy all these things from. So first we need to import all the necessary libraries. First we need to import all the necessary libraries. Then so here NumPy, as I already said, it handles numerical arrays. Matplotlib for plotting the graphs, and train test split. The SQL scikit-learn model selection. In that module, there is a function called train test split. So we need to import that train test split function. Then only we can use that in the program. So another, we are using linear regression to we are using linear regression to predicting the price based on the house area. So for that, we importing linear regression class here. And another thing, for the model evaluation, we use mean squared error. So it contains in sklearn metrics. So I will copy the another two lines. Yeah. So here we have input variable named X. We have one feature. So we are using this feature. We have another, this is the label Y. So when we give 500 as 500 as house area, we will get 5 lakhs rupees. If it is 600 area, we will get 6 lakh rupees. and 707. So this is a good program we can use. We can to learn machine learning. So we use this data to train the system. So we are saying that if we give 500, we will get 5 lakh rupees. If the house if the house area is 600 square feet, then we will get 6 lakhs rupees. So likewise, we are training the system. So for that, so here we are using new numpy's array and numpy's array, and in what is the use of this reshape? This reshape function is used to reshape function is used to this is we know that this is a one-dimensional array. We need to make it as two-dimensional array. For that, we use this reshape function, because two-dimensional array is necessary for this machine learning, sklearn machine learning.
Excuse me, sir.
Yeah.
Sir, can you zoom in a little bit this coding area?
Yeah. Is it good?
Okay, thank you. Thank you.
Yeah. So S is the input variable and Y is the label. So this machine learning supervised machine learning. So we are giving X and we are setting the labels, and the need of this reshape function. So because machine learning models, we have number of features. Here we are giving only one feature. So it's only one-dimensional array, and we are putting it as two-dimensional array. So the one column. So we can see what is the value of that. So if it is not there, it will print like it is a one-dimensional array. NumPy, there is some ndim property. So if we run that, we get 1. That means it's an one-dimensional array. So we are using this readshape function in order to make it as two-dimensional array. So when we run this, that NumPy property ndim, so it will print 2. And so if we print now, we can see that it's a two-dimensional array like this. So before that, it was not like that. So there is only one feature. We need to convert that to two-dimensional array. Then this line we are using the function train test split. So here we already imported that function from this model selection module. We imported this train test split function. So here we are giving that input data and the output data, and we are saying that the test size should be 0.2. That means 20% of the data should be treated as test data, and the remaining 80% data should be treated as training data. So in order to split that, we are using this train test split function. So we will get data in xtrain, and this xtrain we get the training data, and the test data we get in xtest. So the label data, y is for label. So if we print, we can see that so out of this 1, 2, 3, 4, 5, we have total seven input data. Out of that 7 data, 5 data take it as training data, and another 2 data. So this is the training data. Another 2 data comes under the test data. So that split occurs there. Then Y train, we get corresponding output data, and in the test variable, we get the corresponding Y data also. So 80% of data used for training the model and 20% of data used for testing the model. And there is another parameter, that random state equal to 42, which ensures split remains the same every time you run the code. If that split changes, the training will not done correctly. So for that, we are using this random state equal to 42, no other meaning. So when we give that, every time when we run the code, the split will be same. So this is the model creation and training.
Excuse me, sir.
Yeah.
Sir, how do you decide which data for training and which data for testing in this?
So yeah, in this case, we are
I
not
mean,
setting like that. We are giving our training data, and that system can take random wise 20% of data can be used. Yeah.
Okay. Thank you.
Yeah. Otherwise, we can give like that. We can give extrain this data, and another we can put X test another two. If we need to do like that, we can do like that. But this function we can use. So this function will be used for everywhere for splitting the training data and test data. Understood? Yeah. So here,
Yes, sir.
yeah. Here the training is undergoing. So here model is the object of linear regression class, and so in that class there is a function named fit. In that fit, here we are calling the model. We are calling. We are using linear regression algorithm, and here it's training. Training is doing here. So. So we are using train data for training the model. So we are giving X train and Y train. So training undergoes there. So dot fit tells the model to learn the relationship between X train and Y train. So as in the last class, we in the case of linear regression, the slope and intercept will be calculated based on the formula y is equal to mx plus c. So we can see that. So after that, we need to predict. We need to predict on the test data. So the code is for that. So we have trained data, and we are using the test data for predicting the. So this is the code to predict the test data. So here the evaluation is, so we are evaluating the model, how it works with the test data. So this is the new data. We can check the new data with the test data, this Y test and Y prep. So we can evaluate like that. So we can print that predicted value. So predicted value for test data is 5.6. 5.6 is the predicted value. We can see after that. So in order to evaluate the regression, we use mean squared error. So in order to evaluate the model, we use mean squared error. In the mean squared error, we give these two data. This is the actual test data. This is the predicted data. So by using that, so we get something like 7.099 mean squared error. So there is some e raised to minus 30. That means it nears to 0. So there is no error. And so our model is perfectly good, and there is no error, and accuracy is 100%. So we can print the slope and intercept like this. Slope and intercept means y is equal to mx plus c. So in the case of linear regression, the equation is y is equal to mx plus c. So for every x data, this m and c are, m is coefficient and c is intercept. So we will get that by calculating the code. So we can print that. So here the slope is 0.01. Slope is 0.01 and intercept is again 5 point something and e raised to minus 15. You see this. So this is also becomes 0. So this is the trained data and the test data. So we can predicting a new value for yeah 1300. Why we give like this means it should be two-dimensional array. So the x should be the new area should be two-dimensional array. Currently we have only one feature. We can have more than one feature, but we are in this case we are giving only one feature. So so because of that we need to give us a two-dimensional array. So we give like this. So the new area. So we can use the predict function for predicting the new area. So we can print. So here, this is an unseen input, unseen data, 1300 square feet. So we train the model with our this data, and we can see the output. So for output, so this is the f string. I think you all know that it's in Python. So we can format a string by using this f string. So it's very simple because we are setting like we start a double quotes here and another double quotes here. So in order to evaluate an expression, we can give it this and curly braces. So we will get the predicted price for new area. So, and the square feet house. So we can run this cell. So it's 13 lakhs. So we can see how we can check how we get this. So we can take a calculator. So for 1300 is our x, mx plus c. So x is 1300, m is 0.01. So into 0.01. That is our slope and plus 0. So if we get 30. So this is the linear regression. Why it's working correctly means there is some correct. It's a linear regression, and if we can draw, we can show it in our using matplotlib. We can draw that. Yeah. Here we are using matplotlib for plotting the code. So here we are using scatter. So here we are importing pyplot as PLT. So we are using PLT here. PLT.scatter we call scatter function. So we give the input data and the output data. So we are using we are calling plot in order to plot the line. So x data with so we can run. So it's a straight line. So because of that the intercept is 0, and we get the correct data for that 1300. So y is equal to mx plus c. Because of that we get that. So we are moving to another. I think it's clear. So this is a very good program to to learn machine learning, because before that, because we are giving this x data and y data, and we are based on this data, we are training the system, training the machine. So based on that, we checked we evaluated our model, and we identified the slope and intercept also. So y is equal to mx plus c. Okay. So M is equal to slope, C is equal to intercept. So you can extract this from the model. So another thing is, we are going to, we did a program in linear regression. So regression, so we moved to a classification program. So we in the last session, Dr. Srinu already mentioned about classification. And classification means it's also a supervised learning technique where the goal is to predict a category. So in the regression case, we are finding a number. So here the output will be a category. It's a classification. If output is a number, means it's regression. So examples, email, spam or not spam. So if in the case of images, we can identify whether it's cat or dog. We can, in the case of students, pass or fail, medical test, disease, present or. So in the case of news, we can classify it's politics or sports news or tech news or entertainment news. So another program we are using, iris dataset. So we are using iris dataset for classification. So here we are using the algorithm k nearest neighbors, So we can understand understand the dataset. So iris dataset is a flower dataset. So we have different features in that flower. Different features are sepal length, sepal width, petal length and petal width. So these are the 4 features. So in the last program, we have only one feature, that's X and Y. So here we will have 4 features, and the labels are setosa, then versicolor, then virginica. So 3 types of flowers. One is setosa, and another is versicolor, and another is virginica. So this is classification. Instead of predicted number, we are predicting a category. So the KNN algorithm simply checks amongst the nearest neighbors in the data set which class is most common. That all covered in the last session. So that becomes the prediction. So we can see how. So here we are using. So this is a built-in data set in the scikit-learn. So in the scikit-learn framework, there is a data sets, and in that lot of built-in data sets are there. So we are using that built-in data set named the iris data set. So it's a ready-made data set for classification. So in order to learn the classification, we can use that data set. So for more, again, we are using the same train test split for splitting the training data and test data. And here we are using k neighbors classifier. So it's under neighbors, scikit-learn neighbors. It's under there. Under that module, there is a k neighbors classifier object or class. We can say like that. And in order to evaluate the model, we can use different functions like accuracy score. We already discussed about in the last session, accuracy and about classification and confusion metrics. We can use all these things. And here we are using pandas. Pandas is used to create a data frame for clean tabular display. So in order to cleaning the data or for feature engineering, and for all that, we are using pandas library for that. So I am. So we are calling the load iris. When we call the load iris function, the data will be loaded into this variable iris. So we can see the data. So there are a lot of data in the iris data set. So we can see values of 4 features for sepal. Sepal. Yeah, sepal length, sepal width, and petal length, petal width. That's the 4 features of this. In order to identify a flower, we have these 4 features. So, and we have different values there. 5.1 is the sepal length, and 3.5 is the another sepal width. Then petal 1.4 is the petal. So by giving this data, there will be a label like it is it setosa or versicolor or virginica. So there are 3 types of flowers. So I just print this in order to view the data. So this iris object has 2 properties like feature names and target names. So if we print like, so I think we can comment this. So yeah, these are the 4 features. So these are all built-in properties. So when we give feature names, we get the data set feature names that we already discussed: sepal length, sepal width. These are the 4 features, and these are the 3 labels, 3 target classes, 3 labels. What type of flowers? If it is setosa or versicolor or virginica. Yeah, here we are using pandas data frame function. So pandas data frame function is for what? It will be like a table. It will be like a table. So column names will be feature names, and the data will be added to this data frame. So in order to for exploratory data analysis EDA, so in order to pre-processing the data, we need to take this data to a data frame. So data frame is a pandas function. So for that, we are using pandas library for that. So if we print df.head. So head is a function of data frame, which will be print the top 4 rows, top 5 rows. Top 5 rows will be printed there. So we can see. So I think we can comment this. So these are the so this head function we can use for seeing the data set data. So these are the first 5 rows of our data set. First 5 rows will be printed when we use the function head. If we use the function tail, the last 5 rows will be printed. So this 0, 1, 2, 3, 4 is the index that's included in the data frame. So it's not part of our data set. The 0, 1, 2, 3, 4, only this data, 4 columns and 5 rows. Now we can see. So we are adding a new column named target. So there we are taking the target. Target means we can see target means in the case of setosa there will be 0, and in the case of versicolor flower it will be 1, and in the case of virginica it will be 2. So that will be stored in the target column. So these are all things it will come under the data pre-processing. We added a new column here that. So now also if we I cut and so we can see that target. So this is the label. So this is the label. So what we understand that the first 5 rows are type of setosa flower. Because of this 0, we can understand that it's a setosa. So we are going to add a new column, species. What is the use of that? Means currently we have this target with a 0 and 1, 2, 3. So we need this label name also. So for 0 it should be Setosa, and 1 it should be versicolor, and 2 it should be Virginica. So for that we are using this apply function, target.apply, and this is a lambda function. I think everyone knows that lambda. Lambda is a Python function. In Python we can use lambda. Lambda is an anonymous function. So for every x data, for every x, no, this x not means that x. So this is the for every target. So in the case of, if it is 0 means it will be Setosa. So target, in the target names we already seen that Setosa, versicolor, everything is there. So that names will be, so in the case of 0, it will in the under this species it will come like Setosa, and for 1 it will come like versicolor. So like that. So we are adding a new column to our data frame, species, and we already added a target column, species. So we can print again for. So 0, this target 0. So these are so there is no space because of this. Because of that, this slash is there, and remaining rows information comes under this here. So presently we have this data frame 1, 2, 3, 4, 5, 6. 6 columns are there. We added 2 new columns, target and species. Target means it's 0, 1, 2. So in order to identify what 0 means, we added a species, and based on these target names, we apply this lambda function, and we mapped all these names there. So this I think we don't need, because we need to. So we are going to split. So now we have X data and Y data. Iris.data comes, its data is used for training. So that's the X data input data, that 4 columns. And target, we are putting it in Y. So that's our label. So again, we are using the train test split for splitting the data. We need to split. We need to provide this X and Y. So X will be, so 20% of data will be put in for testing, and the other 80% for training. So X train, so corresponding Y data is in the Y train variable. So that 20% of test data will be in X test variable, and the corresponding test label Y data will be in the Y test. So the same thing, same functions we already discussed. So there are total 150 rows are there in the iris data. 150 rows are there. So 150 rows, we divided that 150 into 120 training data and 30 test data, because 20% 0.2 test size is 0.2. So so randomly it takes. So whenever we run this, it will not change. So for that, we are setting this random state equal to 42. The same data will be in the training data, and the same data will be in the test data. So as we did for linear regression, we are using here, we are using the algorithm k-neighbors classifier. So here we need to set that neighbors equal to 3. Look at 3 neighbors to classify. So we set that k equal to 3 there. So we are creating an object of k neighbors classifier class. So the model is the object of k neighbors classifier. So we are using the k neighbors KNN algorithm. So the fit function is used for training the model. So for that we are giving train data. This is the X data, input data, and this is the our output data. So the training will happen there. So in that case, we will not get any output. So if we run this, there is no output because training happens there. Then we need to evaluate our model. So for that we can use predict function. So for that predict, we are evaluating the model. So for that we separated the data for test. So we are putting our test data here, and we are getting a new data YPRED. We are getting a new data. We need to evaluate how this YPRED with this Y test. We need to evaluate this Y test and YPRED. So this is the prediction with the test data what we get. So in that case, it's training happens, and after that we are evaluating the model with the test data by using the function predict. So we need to find the accuracy of this model. So because for that we can use the accuracy score. We already imported that here. From metrics module. We imported the accuracy score and the classification report and the confusion. All these we already discussed in the last session. So what is classification and what is accuracy? So we can run this and we can find the accuracy of our model. And you can see we are giving the two arguments as test data and the predicted data. So we need to check the predicted data with the test data. We need to find the accuracy with the test data and with the predicted data. So in order to find the percentage only, we are multiply with 100 in order to find the percentage. And for rounding to 2, we are using the round function. So accuracy is 100%. Accuracy is 100%. Then classification report. We can see the classification report. In the classification report, we can see precision, recall, F1 score, and the support. So about all these things already discussed in the last session. So it helps you understand how well your model predicted each class individually. So that's the use of this classification report. So we can see like this. So we get the accuracy 1. And this is the samples. We have 30 30 data as test data. So in the 30 data, there are 10 Setosa and 9 versicolor and 11 Virginica. So 10 plus 20, 30. So 100% accuracy. So everything is 1. Precision, recall, F1 score because of this 100%. So confusion metrics also already discussed about. So that also we can see. So the confusion metrics. So here actual with the predicted. So actual with the predicted. First row is for Setosa. Setosa here. Setosa actual. Setosa predicted. And this Virginica actual. Virginica predicted. No, versicolor actual. Versicolor predicted. Then versicolor Virginica actual and Virginica predicted. So these are confusion metrics. Yeah. So we use iris data for what iris data. We use iris data, and we use KNN classifier. And we train the data by splitting training and test data. So after that, we evaluated the model, and we found the accuracy, and we found the confusion matrix and classification report and all. So we can after that we can predict. We need to predict for a new value. So we can see how can we do that. So if we get a value like, so this is the deployment, or we can say like that. So we trained the model, and we evaluated the model, and we use that model to predict a new inputs. So we are giving like this. So I already told that the input data should be in two-dimensional matrix. So we are giving like this. We are giving 4 input values. So setos, but sepal length, sepal width, petal length, and petal width. If we give like this, we need to find which flower. We need to find, if we give these type of features, we need to find which flower. So for that, this is a new flower measurement. Note the sample is inside double brackets, a two-dimensional array. So we can use predict. Predict function is used to predict the label. So we give this sample data. So we can give a number of values by separating comma. So because of that, we will get number of values. So we need to get for first one, then we are giving like this of 0. So we can print this predicted class. We can see which one is that. I think we can comment all these things. So predicted class is 2. That means it's a Virginica. So 0 for Setosa, 1 for versicolor, and 2 for Virginica. So it's a predicted class is, if we give the data, input data like this, we will get, we can identify which category. So it's a classification. And if we give that class into the target names, so we have these target names there. So we will get the correct information. So we can print that. So it's Virginica. So this is the so this is an example for classification. So we already seen regression. So now we seen classification with the KNN. So we move to clustering, unsupervised learning. Unsupervised learning means finds hidden patterns. So we have a lot of algorithms, but we don't have time to go through all these algorithms. So first we have seen 2 programs, one for regression under the supervised learning, one for regression and one for classification. For regression, we use the algorithm linear regression, and for classification, we use KNN classification. And so next, unsupervised learning. So finds hidden patterns in unlabeled data. Suppose you have thousands of customer purchase records, but no labels like high spender or low spender. How can we group similar customers together? That's unsupervised learning. There will not be any label. So I am not saying anything. So we can see a program like build a K-means clustering model that groups customers as budget customers, premium, and occasional, and predicts the cluster of a new customer input. We are doing that program now. So we have data. So here I am taking a customer data Excel because I am not using any input built-in dataset. So this is the customer data. I stored that in our Atal FDP folder in my drive, customer data. So we have data like this. We have three columns. One customer ID, another column is annual income and spending score. So we are using this data for. So we are using this, and we need to cluster, or we need to identify which all customers are under budget customers, and which all customers are occasional customers, and which all customers are premium customers. That is our problem. So we are going to do that now. So here we are using k-means algorithm. So for that we need to import k-means. So for clustering, we use k-means algorithm for that. So we need to import all that things. And for our plotting, we use matplotlib. We already seen that. And this is the new thing. In order to read that Excel data, it's already there in my drive. So in order to read that data, we need to. So we are using this Colab, and it's in our drive. So it's the Excel data is also in my drive. So we are not uploading anything. So we need to read that Excel data from there. For that, first we need to mount our drive. So for that, we are importing. So imports the drive module provided by Google Colab to connect to your Google Drive. So then we need to mount our Google Drive to the Colab file system at the path content/drive. This is the default path. So we need to give like this. So we need to mount our. So we need to provide the access also. Otherwise, the system will not. We cannot read that this. After this, you can read or write files from Drive. After mounting this folder, we can. After mounting this Google Drive folder, we can read files from that. So for that, we have a function in the pandas library named read Excel. So we can give the so content/drive is there. So my drive. Under that my drive, there is a folder Colab notebooks. Under that, there is a folder Atal FDP. Inside that folder, my file is there, customer data.excel. So we can give like this. So we can run, and again we are using this head function in order to print the first 5 rows from that Excel. So when we run this, so permit this notebook to access your Google Drive files. So we need to give permission for that. I think it's not that. It's a problem because I have two accounts and one my personal and one my company. So that file is there with my personal account. That's the problem. Yeah, I think we can run here. We can run here. So otherwise, because it's there correct. So we need to give access to that. Yeah, it's mounted. The drive is mounted now. So the data read from this customer data.xls and it took to our data frame. So this is the pandas data frame. So data frame means it's like a table. We took the data from Excel to our machine's memory or data variable. It's a data frame. So if we use this head function, that first five, so we can see. So this is the first-five data. First-five data we can see. One 115,666. So this is the first-five data. So so here we can see the data here. Data is the pandas data frame. So our features are annual income and spending score. Annual income and spending scores as the feature are input variables. So we took that to the X data. So we are using K-means clustering. So here we are saying we need to create three clusters: one for budget customers, and two for premium customers, and another for occasional customers. So we give clusters equal to 3. We need to cluster these data to 3 clusters, one for budget and one for occasional and one for premium customers. So here training will be done here, as we already seen in another two programs. Yeah, we are here creating a K-means cluster, K-means object. We want to form 3 clusters, groups of customers. Random state equal to 0 means fixes the random seed, so we get the same clusters every time, as we have seen in another random state equal to 42 like. So it should be same clusters. Runs the K-means algorithm on X data, randomly initializes 3 centers, assign each data point to the nearest center, recomputes the centers based on assigned points, repeats until convergence. So there is no label data in the case of this unsupervised labeling. So here we get the labels. So we get the labels and we take that labels to a new column named cluster. So new column named cluster. So if we run this, we will get that cluster labels. So this is the cluster labels. That means for one first record, it will be 1, and the second record, it will be 2, and 1, 2, 0, 0, 1, 2. So that's the 3 clusters. It assigned like that. So instead of giving labels, the k-means identified these labels. So 3 clusters, 0, 1, and 2. So this for this 150 records, 150 rows are there in our Excel. No, I don't know how much 150 for iris data. So here we have around 100 data, I think 100 data. So for 100 data, we have this cluster labels. We got this 100 labels there. Right, to call these things. So as the time is. So if we need to find the cluster centers, so labels will be for 0, 1, 2, showing the cluster index of each customer. And centroid coordinates, if we need to find, we can use the cluster centers property. K-means dot labels, each row of cluster centers corresponds to one cluster. So K-means dot labels means which cluster each point belongs to, and cluster centers coordinates of the cluster centroids. So now we can map this, or we can map after seeing this plotting, we can plot that. So no need now. Commented. So we can run this. We can comment other. So here annual income, spending, X of annual income, spending score, and C data of cluster. This is we identified. That's the new column we added to our data frame. Labels, we get that. So based on that, we are plotting that. So scatter means that so all the values are plotting like this. So this is for budget customers. This is, we can do like that, and we can, based on that, we can map. This is budget, and this is occasional, and this is premium customers. We can identify. So after seeing this, after seeing this we can add a dictionary, like for 0 it should be budget, for 1 it should be premium, and 2 it should be occasional. So we get the labels like 0 for first cluster, and 1 for second cluster, and 2 for third cluster. So we use map function, and we are adding a new column segment. So based on that, another column will be added. So for cluster, there is, if it is 0, it will be mapped as budget, and if it is 1, it will be then in this column it will be premium, and if it is 2, in this column it will be occasional. And if we want to find the centroids, cluster centers, so that centroids, we can use this code. So cluster centers X coordinates, and based on this cluster centers Y coordinate, it will be marked like this. So based on this centroids, its clustering happens. So this is budget, premium, and occasional. So if we have a new data and we need to find, we have a new prediction, we need to predict for new input, new customer. So new customer with 30 as annual income and what spending score is 60. We can give that and we can use predict for that, and there will be, we will get a cluster, and if we get the cluster names of that cluster, we will get whether it is a budget or so new customer, we give 30 and 60 and belongs to occasional segment. So it's something like that. We get the, we predict with that data. I think time is going. So I will show you deep learning also. So otherwise, deep learning. Deep learning, we are using ANN here, ANN neural network. So for that we have different, we are using this TensorFlow framework. Okay, here this is a CSV file we are retrieving from. So in that data, you can see. I think if I show this, it will be take not much of time. So we are retrieving a CSV file from a GitHub. So we are giving that URL here and the same read CSV function. So we can see there are 30 columns, I think. So we are using this data in order to identify whether a customer churn or not, or customer will exist or customer will leave. So this is a telecom data. So so this is the function in order to drop the customer. So in the data pre-processing side, we don't need this customer ID. So we can drop that from our data frame. So for that, this drop function is using. So axis equal to 1 means we need to, axis equal to 1 means we need to drop the column customer ID. So axis equal to 0 means it will be used for dropping the rows. In place equal to true means the same data frame will be modified. Otherwise, we can copy to another variable. And here we are using all these normalization and scaling and all. So this we are total charges. There is a total charges there. So I think if I explain all this code, I think our time will be, so it's 9 o'clock. So do we need to finish now? Do we need to conclude now? Anyway, I commented every code, so I will share this Python notebook, IPython notebook, this Colab file. So you will get this, and you can. So we can conclude now. Is it okay? Or hello? So this is a neural network, artificial neural network. Here we are. I plan to show. So sequential. Here this we are using this model sequential layer. We have different. This is our input layer, and this is the hidden layer, and this is the output layer. Here we use the activation function ReLU, and for this sigmoid, we need to find whether the customer leaves or not with the telecom data. So can I conclude now?
Yes, sir.
Okay.
Hello.
Yeah.
Am I audible? So, dear
Yes.
participants, if you have any queries, you can ask. Otherwise, we can wind up our session. Hello.
Yeah. I cannot complete everything because of this time and.
Okay, sir. Okay, it's okay. No worries.
Yeah.
Okay, myself, Manjula, Assistant Professor, Department of Computer Science. I am here to summarize the session on hands-on machine learning and deep learning using Python. Sir, it was a highly interactive and very useful for our participants. Our resource person, Mr. Dilip Ji, explained the concepts in a clear and simple manner, focusing on how ML and DL are used in real life. The session started with an introduction to machine learning, its importance, and different types of libraries. Participants were shown how to load dataset, clean data, and build basic ML models such as regressions, classifications, and clusters using algorithms such as linear regressions, KNN, and K means. The demonstration helped everyone understand how this model works behind the scenes. A key highlight of the session was the real-time practical exposure using Google Colab. The resource person guided the participant step by step on how to write Python code, run ML models, visualize output, and test results directly in Colab. This made the session highly practical and easy to follow, even for beginners. In the next part, the speaker introduced deep learning using TensorFlow in Google Colab. Participants were shown how to build and train a basic neural network model. Seeing the coding and output live on Colab boosted the confidence of the participants to try the technique. The session was very engaging. The hands-on experience made the concepts more meaningful and helped participants understand how ML and DL are applied in real-world application. Overall, the session was highly effective, practical, and inspiring. It gave everyone strong foundational skill and motivated them to explore machine learning and deep learning further. Thank you, sir. Once again, thank you for your valuable time spending with us.
Yeah, in this Colab file, I plan to explain two things. One for ANN deep learning ANN. So if you look into that, you will get an idea when I share. So after that, by using this CNN, so there is one CIFAR dataset there under this Keras dataset. So for the classes are airplane, automobile, bird, cat. So there are 60,000 images. So in this code, we are training the model and we are saving the model and we are saving and downloading the model. We can saving and download the model to our machine. So this is the code for that. Just I say that because you can when you. So we can train our model and we can download our model to our. And in this session, we are uploading that model and we can upload any file. So from internet, so we can evaluate our. So if we give a bird image of a bird, it will say it is a bird. So like that, I use this CIFAR function for CNN. So CNN you can see here. So that first program is ANN and this is CNN, convolutional deep learning neural network. So thank you. Is there anything?
Thank you, sir. Let us welcome Ms. Suhaila for official vote of thanks. Suhaila, ma'am.
Good
Hello.
evening to all. On behalf of the
Yes, sir.
Majlis Arts and Science College, Paramanur, I sincerely thank Mr. Dilipji for delivering an insightful and practical session on ML and TL using Python. Your valuable time and expertise are truly appreciated. My thanks to Mr. Ajay Kumar, Head of the Computer Science Department, for the welcome address, and to Ms. Manjula H. for serving as the rapporteur. A special thanks to Ms. Chitira PC for her technical support. Finally, I thank all participants for their active participation. Thank you all.
Okay, bye. Thank you.